When computers started becoming mainstream in 1970s and 1980s, we faced a challenge. We needed an operating system to access the resources of the hardware. Now the operating system itself cannot directly access the hardware resources, but depends on kernel. So there were a couple of kernels built in at that time. For example, we have Linux kernel and Windows kernel. So the Linux operating systems were built on top of the Linux kernel, and Windows operating system was built on top of Windows kernel. These operating systems access the hardware resources through these kernels. The operating system cannot directly access the resources of the hardware, but actually depends on the Linux or Windows kernels accordingly. After that, developers started developing applications such as Notepad or VS Code. These applications were actually dependent on the OS. Through OS, they have access to the hardware resources, but they do not directly access again the hardware. But the hardware resources actually allocated to operating system through kernel. But the developer who is actually developing an applications on top of operating system need not to know about the workings of the kernel, how the CPU is allocated, how the memory is managed, etc. etc. So the developer who is working on an application needs to focus solely on developing his own application. He need not to know about the process management, memory allocation that the kernel does, because he does not require to do so. So that created a layer of abstract. The developer is using the kernel's capabilities for his applications, but he need not to know about the workings of the kernel. So this created an abstraction. You see, now the AI revolution is happening. The AI agents know all the programming languages that are available on the planet Earth, possibly. And these AI agents are capable of writing the code by themselves. So there is one more layer of abstraction. Initially, developers were started developing applications in C, Python, Java, or any other programming language on top of they weren't needed to actually know about the inner workings of kernels. So there was one layer of abstraction. Now on top of programming language, we have AI agents. These AI agents possibly, as I mentioned, know all the programming languages and are capable of writing the code in any programming language. But these AI agents actually require instructions. These AI agents require prompts. The instructions or prompts can be written in Markdown file. This Markdown file is very close to the natural language. Like how we write something in English, we can also write the same thing in Markdown language. There are some syntax changes. The Markdown language itself is not a programming language. The mechanism is not built in the Markdown language to actually allocate memory or something like that, like we have in C programming language where we can actually allocate the memory. But the AI agents, since they all know the programming language, if we give the instruction to the AI agent, they can write the code in such a way that we can actually build applications, build software, build systems using that Markdown language. So initially we have hardware. On top of that, there was a kernel. On top of that, there was operating system. On top of that, there was programming language. And now, on top of programming language, we actually have AI agents. And on top of AI agents, we can say we have the Markdown language. In this Markdown language, we can write instructions to the AI agent, so the AI agent can actually read those instructions and can convert that into a programming language and can actually build an application for us. So that actually creates a layer of abstraction on top of programming language. So in the future, there might be developers who are solely working on these instruction files, creating instruction files, and they need not to know about the any programming language, because the AI agent can write the programming language itself. Now there is a problem with abstract. You see, when the kernel was developed, only have one Linux kernel. There is no replacement for Linux kernel. And also we have only one Windows kernel, and there is no replacement for Windows kernel. You can actually write your own Windows kernel. The software is written and it can be read. It is actually predictable, like how the software is, the kernel is. But you see over here the abstraction with AI agents and the programming language. The AI agent can actually produce result different each time. For example, if you give one instruction now, the AI agent can produce a result. And the second time when you again the same instruction, it can actually give the different result. So there is a possibility that the AI agent can do different things each time, so there was no predictability. But the kernel was actually predictable. I mean, it is already written, so there is only one kernel. So with respect to the AI agents, we can actually have this abstraction as a drawback for us, because the AI agent can write the code differently each time for the same so we need to come up with the instructions in such a way that each time the AI agent produces the same result for a specific instructions. So as a developer, maybe going in the future, we might need to write these instructions which make the AI agent to produce a predictable result.